Hey, I'm Pierre. I'm working with Near AI for quite some time now. I'm doing mostly like a lot of engineering, and today I'm going to present you what we've been working on. So as most of you have heard about these autonomous agents becoming super mainstream, most of the people have been running them on Mac Minis because like they are quite afraid of putting them outside in the wild or on some AWS instance or anywhere. And so what we are trying to achieve is that you don't have to buy Mac Minis anymore. You can just use our infra. Yeah. Oh, fantastic. Okay. So yeah, beyond Mac Mini. So I'm going to talk a lot about TEs. It's the technology we are using to achieve this. First, I'm going to try to quickly introduce you to this like technology. It's quite like fuzzy, but yeah, I'm trying to make sense for you. And then we'll do like a live demo and deploying an Ironclaw or OpenClaw into our infra. Great. So in the crowd, who heard about TEs in the past? Oh, some people. Nice. So basically, it's a technology that allows you to run things in a totally like confidential manner. Nobody can actually see what you are running on this, even if you have physical access to the machine. Okay, so these agents are getting more and more capable. So we are giving them like wallets, API keys, a bunch of private data. But the issue is right now, if you use one of these cloud providers, they can actually see everything that's happening on this server. They can literally access the machine and read the RAM, read whatever bits are coming through. But what if there is a cloud provider that allows you to run your agents in a fully like confidential and private manner? So to do this, we are using trusted execution environment, so it's like TEs. It's essentially a vault that's running inside your computer. It's the exact same principles in the cloud. So basically, Intel, AMD, all these like major like chip provider have been working on this technology for quite some time. And as I said, like it's some hardware isolated like secure area in your processor, and meaning that nobody can actually see anything that's running inside of this. So with TEs, the assumption is that you don't trust the operating system, you don't trust the hypervisor, you don't trust the cloud provider, and you don't trust like physical access, like meaning that you assume that the attacker, the hacker, has physical access to your machine. And so with TEs, basically you have guarantees that it's actually your agent running inside of this, it's your code, your data, your private keys, and your memory is fully encrypted. So how it works, it's kind of magic. So first of all, there is what's called like hardware root of trust. It's basically, so let's take the example of Intel. When they print your chip, inside of this, they embed some secret key that you cannot access. If you can access the secret key, then everything breaks, basically. So there is physically no way to access it. And so from this secret key, then everything is encrypted. So the memory is being encrypted inside the CPU and the RAM using this secret key. And when you run some workload, so in this example here, we're going to run an agent, but it could be like any kind of software. You get a bunch of, we call it measurements, but basically it's like you take like the fingerprint of your software, and then Intel, basically with the module they have running inside the CPU, they have a proof that says like, oh, this software is running inside the secure enclave, it's using this secret key to be signed, and these are the measurements. And then you have what's called like remote attestation. It's basically you take these measurements, you take the expected measurements, so you have to have expected measures to be sure that it's actually what's running, what you expect to be running, and then you verify the two, and if it matches, you know it's the correct software. So yeah, as these agents are becoming more and more popular and useful, now we are giving them, as I said, like wallets, private keys, sensitive data, and now they are able to do more and more like financial transactions through near intents. For example, if you came to NearCon, it was a pretty hot topic. And so how it works on our infra. So as a user, you just 1 or 2 clicks, you deploy an agent and our infra, and then blah, 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 you end up in an enclave, so it's another name for TEs. And you as a user, you can do attestations. I'm going to quickly show you what it looks like. And yeah, so also at Near AI, we've been working a lot on like private AI inference. It's basically, we take these huge LLMs and we put them inside the secure enclaves. So we guarantee you that we cannot see your prompts and we cannot see the response from this AI, from these like large language models. So this has been running in production for something like 6-7 months, and we have a bunch of like enterprise partners. But now we are coming for agents. And yeah, so now you can toss your Mac Mini and just use our TEs. So yeah, as a builder, now you can actually like build a bunch of agents, and then as a user, there is a way for you to actually verify that this agent is like correct and it's running what it's supposed to be running. So you don't have any trust on the actual builder anymore. And also it creates like a huge ecosystem of a network of agents that now can verify each other. You have identity that comes with this. And yeah, so now you trust the hardware, so you still have to trust Intel that they are not like putting malware into the CPU, and you still have to trust them. So that's the only bottleneck, but you can verify everything. I just want to say about like Intel, there's a bunch of like audits. So normally it's safe, but you never know. But a lot of researchers are working on this. Yeah, so if you want to try, so we have like your first instance is completely free. So I'm gonna go on this website in a second. If you guys, yeah. So I'm just leaving a minute for people to scan. Okay, all good. Yeah, so I have on this specific account, so I'm on the free plan, so I can only do one agent. But so right now you can pick between OpenClaw, which is a very famous autonomous agent framework, and you can pick also like IronClaw, which is our like open source variation of OpenClaw, which is much more secure. Ilya has been talking a lot about it already, so I won't do the same speech again. But yeah, so here, so right now we enforce you to have some SSH key. You don't necessarily have to know what it is, but just you have to download it. And it's just in case, so since we don't have access to your agent, there is no way for us to recover access. So it's more technical, but it's a way for you to get back access to your agent and retrieve all the data out of this. And then we're gonna activate it. So it's gonna take a minute. I don't know how much time I have. Oh, plenty of time. Okay, so basically now we are like provisioning this agent inside our like TE infra. It's gonna take like 30, 40 seconds. And after this, we can send a message, and then I'm happy to answer any questions. So once you get this agent, you get like all the measurements I've been talking about. So also you will be able to do the same things on your side and actually verify that we are running the agent that we are promising to be running, not something that's malicious, because the code is open source and you get the measurements, so you can replay the measurements on your side. So now the instance is running. I'm logging into my agent. So this is an IronClaw agent. It's the exact same process for OpenClaw. And then you can just start. Oh, let me zoom in. Yeah, you can start asking some questions. Let's say, what do you prefer between a croissant? No, and a donut, because we are in the US. I think I know the answer already. Let me just say an amazing croissant, just to be sure. Yeah. And yeah, so this is using our like inference stack. So here again, if you want, you would be able to verify that we are actually sending this request in our like T infra. And same, you get like oh, amazing croissant. It's very, very surprising. Yeah, so I won't have too much time to go into like, so this is basically the measurements I've been talking about. We have a bunch of docs. You guys should go read it, or I'm happy to answer more questions at the end. But basically, like, using the full report, you would be able to verify that we are fully genuine and secure. And yeah, so after this, once you have your IronClaw agent, it's basically the same as you would do with OpenClaw. You can do whatever, like do your finance. I wouldn't recommend like healthcare. Yeah, whatever. Filter your emails, a bunch of other things. But yeah, that's basically it. So with IronClaw, you have a bunch of logs, which is cool. You don't have this on OpenClaw. You can install a bunch of extensions, which is, as Ilya said, is running inside these WASM modules, which are much more resilient compared to OpenClaw, running everything on the local host. And yeah, that's it for me. And yeah, thanks for listening. And I'm happy to answer any questions. Yeah. Yeah. So yeah. So the question is where this like chat is being stored when we have the discussion with the AI agent. So actually, it lives. So your agent comes with, I think it's something like 40 gigabytes of disk, and so it's being stored on the disk. We have, it's a bit technical again, but we have some KMS that encrypts this storage, and only you can access it. Yeah. And oh yeah, it's fine.
Hey, donuts are better, by the way. But can I give wallet access to this Iron Claw? Is that a feature that you have added?
Yeah, so we are working on the wallet aspect. I mean, it's going very fast. Maybe I lost the update. I missed the updates from today. But yeah, we are. The idea is that yes, your Iron Club will get a wallet, and then you can trade on a bunch of different chains using near intents or whatever other. Feel free to create an extension, and you can trade on whatever chain you want. But I think. I mean, the extensions have some like logic that they have to follow. So you can call them as guardrails, but we don't necessarily like enforce guardrails on the LLMs itself. It's more like the code of the extension that enforces some guardrails.
Thank you for the talk and the live demo. Are you welcoming open source contributions at Ironclaw?
Oh yeah, of course. Yeah, let me show you actually. I hope nothing's gonna show up. You never know what I do on this. Um, yeah, so this is like our repo. It's fully open source. We have now reached more than 3.5 thousand stars. It's pretty cool to see. And yeah, you can see that Henry and Claude are working hard on it. But yeah, we are already at, yeah, we are launching a bunch of different releases, like every other day or something, because a lot of things are coming through. But yeah, please contribute. We have a bunch of issues and pull requests if you want to review or put your Iron Claw to reviewing these PRs. Yeah, so right now we don't auto-upgrade your Iron Claw. There is a way for you to do it. So we are working right now on adding some button on this like dashboard. Actually, I didn't show this dashboard, but so this is the dashboard on our. So this is agent.near.ai. So this is like our like agent management stack. This is where we start. This is from where we started an agent before, and so this is the screen where you land on after you started your agent. And yeah, so here you would have a button. I don't know where it's going to be, but yeah, upgrade my instance, something like this. Yeah, and you can see like all the. So right now it's very alpha, but you can see all the LLM calls that has been done by your agent. Right now I only did one right before this, right? And yeah, on the free plan you get 3 million tokens. So I used 15% already. I mean, this is from my previous instances, but yeah, so we have a generous free tier. Yeah, so we have, so basically, near AI, so we've been first, like a year and a half ago, something like this, we were working mostly on agents things, and then the need was more towards like a private inference, and also like we felt the need for this, so we moved back to basically doing like only private inference, and so basically the core business right now is called cloud.near.ai, but basically it's a, oh, I'm not logged in. Let's see, but it's a like OpenAI compatible API where you have the same like proofs and stuff that we cannot see your requests and the response from the AI. So this is like we have a bunch of different models and yeah. So yeah, so only the private ones we built in private are running on our infrastructure. Anonymized, we are just like proxying the calls to this major providers. Hmm? Yeah, exactly. Yeah, yes, that's the idea. And yeah, the latest addition was GLM5 last week. Yeah.
Finished? Yeah. Okay, let's give it up for Pierre. Fresh project, so please contribute.